Welcome to Brain Vision.
Alright, we're given that the angular velocity is 5 rads per second and the angular acceleration is 10 rads per second squared. And we want to find the velocity and acceleration at point A and B in the component form, in components of the normal and tangential axis. So we're not using I, J, and K. We're not using the X, Y, and Z axis. We're using the N and T axis. Alright, so first things first, let's do the velocity A. We can simply substitute the value. We're given that the radius here is 9, so R is equal to 9 inches. So we simply need to substitute V is equal to R, 9 times angular velocity, which is 5, is equal to 45. Now let's calculate the direction. We can see that the angular velocity is directed this direction, which is along the positive t axis, and so our answer is going to be 45 ET. This ET just represents that is in the t axis, plus 45 ET because in the positive t axis. And don't forget your units, meters, sorry, inches per second. Inches per second. And for the acceleration now at point A. Remember, we have two components, AT, tangential and normal. So for the tangential acceleration, AT is equal to alpha, the radius is 9, times alpha, which is 10. So that's 90. Now the direction, the acceleration is directed towards this, and we can see that this is a negative t, so this is going to be minus ET in inches per second squared. Now for normal acceleration. Normal acceleration is simply centripetal acceleration. It represents this direction. So it's going to be in the n axis. So AN is equal to V squared 45. This V is this velocity we just calculated here. So 45 squared over the radius, which is 9. That's equal to 225 inches per second squared. So let's see the direction now. So this is going to be in the positive n, because this is directed towards the center, in the positive n direction, and it's going to be in En. So for part E, our acceleration is going to be, we just need to add these two to find the resultant, basically. So our acceleration is going to be minus 90 ET plus 225 En, all together in inches per second squared. There we go. And our velocity is plus 45 ET inches per second. Now let's go to part B. This is where it gets a little tricky. B. And so now in B, we need to actually separate this. You can see that it has two sides to it, kind of a right angle. So we need to separate this consider this side and consider this side separately. And to do that, let's start with the velocity. Let's do this side. So we've already calculated this side for the velocity, which is all here. So we don't need to do that again. That's this first part we did here. And so now we need to go to this part. Let's calculate the velocity on this side, taking this side into account. So E is now going to be the radius here is going to be 3. As you can see, the distance from this point A to point B. So which is going to be 3 times the angular velocity, which is 5. That is 15. And let's see the direction. So since the angular velocity is directed like this, if you complete this full circle, we'll be getting something like this. It's going counterclockwise. So at this point, it's going to be tangential here. And so we're going to have it in the positive n direction. 15 en plus 15 en inches per second. And this is just only taking b into account. So let's just put the dash under so we know that it's not the final answer. So the final answer, v for let's call this a so we can differentiate b. So final answer for b for the velocity at point B is going to be, we add these two together, we're taking the resultant. So we're going to have 45 ET plus 15 EN inches per second. Give me a second. Right. So next, we're going to do the acceleration. So it's very important that you pay attention to the signs and you pay attention to the parts you're considering. So for the acceleration, we already have remember we did the tangential and the normal. So let's do the tangential and normal for point B only. So let's put the dash on that. No, we're considering only for point B. And this is going to be the tangential. And so the radius is 3 and the angular acceleration is 10. So we have 3 times 10, which is 30. And the direction is going to be tangential to this. We can see it's going counterclockwise. The angular acceleration is going counterclockwise. So at this point, we go around the full circle. It's going to be tangential in this direction. So we're having it in the negative n direction. So minus en inches per second squared. And finally, for the an dash, we're only considering this part, and the formula we're going to use is the v squared over r. So remember, we're only considering this part, so we're only going to use the velocity for this side, and the velocity for that side we calculated was this was the velocity we calculated. So that is 15 squared over the radius, which is 3. And give me a second to calculate this. And get 75. But let's look at the direction also. The normal, this is normal. So this is directed towards A. It's directed from B towards A to the center. And this is the normal axis here. And this is actually going to be in the tangential direction. axis. So it's going to be negative ET. Negative ET. So finally, to find the acceleration at point B, we need to add these two together. And we're also adding it with this guy here, we calculated. So we're doing minus 90 ET, and remember, let's do this so we can collect like terms. Minus 75 ET, and then let's do the EN, minus 30 EN, and then plus 225 EN. So this is going to be minus 165 ET, and this will be plus 195, I believe, 195 EN. So yeah, so let me write out the answer finally. So for A, we have that the velocity is 45 ET inches per second, and we have that the acceleration is minus 90 ET plus 225 EN inches per second squared. And for B, we have that the velocity is 45 ET plus 15 EN altogether in inches per second. And the acceleration at B is minus 165 ET plus 195 EN altogether in inches per second squared. And that's your final answer.